Let's go through LeetCode 2509, circle length query in a tree. So this one give a binary tree which has 2 power n minus 1 nodes. Actually, this tree you see, we just use the n will represent a tree. That is the root is 1 and its child, for example, 2 and 3. So the left child will be every number, the left child will be 2n. 2, for example, this number is I, then that was 2i. The right child was 2i plus 1. And it gives us integer two-dimensional array query. For each query, it queries some of the number between this n. And for example, this 5 and 3, right? So for this 5 and 3, we use h to connect it. So you'll see it forms a circle, right? The same thing if, for example, 4 and 5, right? So it forms a circle like this. So it asks what is the circle length. Let's return for all of the queries the circle length. So actually for this question is pretty much like find the lowest common accessor. And for this one, to find the lowest common accessor, so if we are query, for example, node P and Q, right? Then if we find a lowest common accessor, that means for this one to P and Q and PQ will forms a circle, right? So that means if we can find how many steps from P to the LCA, right, and Q to LCA, then for example, L1 plus L2, then plus 1, that will be our result. So whether we have some efficient way to get L1 and L2, right? We know every number P and Q, to get its parent, that is P just divided by 2, right? And Q is also Q divided by 2. So we'll say 3 divided by 2, that is 1. So its parent is 1, right? So to get its parent, we just use P or Q divided by 2. So that is will facilitate our query. And this question is pretty much similar to the 16050, right? Lowest common accessor of binary tree, and which give a parents. But this one, to go to its parents, instead of use a parent pointer, we just divided this number by 2. And also, this one, because this tree has a feature that is we can also write, for example, the way like 16050 way, right? So if for example equals 0 when divided by 2, right, then goes to Q, right? And if go to another one so that they meet. But doing like this need some actual it will run 2 circles, right? And for this one, actually, another advantage is that P divided by 2, Q and by 2, right? That the thing is that we don't need to go the same step. That means don't need to P go up 1 step and Q go up steps. We can have another feature which can facilitate our calculation. If Q is smaller than P, right? Then we go P, Q, right? P is smaller than Q. Then we move Q to have Q to its parents, right? And our result just find out how many steps totally, right? Until they meet. And if P is greater, we just move P. If Q is greater, just move Q, right? And in that case, we add all of the steps, and don't forget to add one more. That is the connections for the circles. So let's write code for this. So let's have int m equals queries of the length. And so we're going to have int result equals new int m, right? So what we do is that for int I equals to 0, I smaller than m, I plus plus. So we are going to have int p equals queries I 0 and q equals queries I 1, right? So what we can do is that while p doesn't equal to q, so we trying to see which one is greater, right? If p is greater than q, then we are going to have p divide equal to 2, right? Else, then we will have q divide equal to 2, right? So the thing is that every time, so if that is equal, right, either p or q move, right? So that means our result, let's have a result goes to 0, right? So our result should increase, right? Every time we move one step. In the end, we retain integer array. So result I should increase by 1, right? And so in the end, right? We can have every result need to add one more, right? Because we have a connection. We can have do this arrays will result 1 there. This is a connection H, and in the end, just return result. So doing like this, this tree, this kind of operation will be log n operation, and there are m queries, so that will be m log n time complexity. Let's also convert this to Python code. So let's have m equals length of queries, and we're going to have result equals, let's have 1 multiplied by m. So what we do is for I in range m, we're going to have p q equals queries I. So while p down equal to q, right? So if p greater equal to is greater than q, then we have p divided equal by 2. Else we're going to have a q divided equal to 2, right? And in the end, we just return result. For every move, we should update result. I should plus equal to 1, right?